To give an intro to everybody to the event, feel
Yeah,
free
I
to
just give a
start.
general intro. I'm Jeff Rivich, located in the U.S. I'm currently the chairman of two special interest groups under the Linux Foundation. One is supply chain trade finance. The other one's carbon accounting in action. And so we've those two special interest groups are always interested in getting presenters and information on what's going out in those respective areas. So. What we did is and I really don't remember the inception of it. It was about sometime about a year ago. We came up with the idea of a project that would involve both supply chain, trade finance, and carbon accounting together. And the project we thought of is not so much building out a piece of software, but an area that people have high interest in, and that is systems architecture. So what we started doing is looking at um, doing a demonstration of how architecture cascades all the way from reference architecture that corporations have, all the way down to the solution architecture, the business architecture, the technical architecture. And we developed a project around that. And so we've been defining an architecture for modeling supply chains and on an economic basis, also their carbon emissions. And so we started along that trail of putting together a reference architecture. And again, a reference architecture is somewhat, everybody has one on their laptop, but for carbon accounting, there's reporting systems out there. There are emission networks out there. There are credit systems to buy carbon credits, greenhouse gas credits, and so forth. So what we did is we started looking at ideas around what we could do and around the area modeling, and digital twins came up. And so we started putting together an architecture at a high level of digital twins. And we started out the reference architecture and we're building it out right now. And again, we're putting together this architecture under the guise of Linux Foundation using open source software. And we have reasons why we promote the Linux software as far as some of the advantages it has around channeling and security and so forth. And so our architecture project right now also involves a person, Ed Cheng, who's on the meeting, and he's a PhD student at Cal Berkeley. He's involved in the project, and we're developing this architecture so that when we get done, we will have an architecture on a supply chain digital twin that focuses at a high level on supply chain carbon emissions and greenhouse gas emissions and how to get yourself to net zero. Fantastic, Johnson. This is a perfect lead, and he hit it just perfect. And so. Um, so we're doing that, but we pulled back a bit and thought to ourselves, we're not digital twin experts by any stretch of imagination. Who do we get? And so luckily, SimWell has agreed to give a talk today on their development and use cases around digital twins that they've implemented globally. And so they are the real experts on digital twins. And so that's what we have today is John's going to give some of the use cases, background, so on and so forth about what SimWell does. And that's where we go from there. So that's the origination of our work and around the Linux Foundation about just doing architecture. And again, it's a learning tool for people to go from reference architectures all the way down to technical architectures. But again, we picked up on the digital twin concept and we kind of held back somewhat because we're not experts by any stretch of imagination, but we do now have an expert company, and John's on the call here. So John, you can introduce anything else you want to put in this meeting as far as SimWell. You're free to advertise your company, uh, describe what they do, and we'll go from there.
Yeah, awesome. Thank you, Jeff. And thanks for everybody for joining this session. I don't intend to advertise the company too much, but feel free to ask questions as we go along. I'm excited to share what we've done a little bit and how this can be applied in different ways across supply chain. My hope is it just inspires some different ideas for you guys. And yeah, if anything's unclear, have any questions, anything like that along the way, don't hesitate to drop questions in the chat. And be happy to answer them. Go ahead and share here. Okay, you should be looking at a PowerPoint.
Yep, if we can see it now, John.
Okay, excellent. So
I will say this, just one thing, John, real quick, is when we started looking around for experts on digital twins, your company came up all the time first, whether it was an AI chatbot or whether it was Google Search Direct. SimWell always came up the first the first company. So you guys have quite the footprint. So I just thought I'd add that in there.
Thank you. I appreciate that. Hopefully that's a sign of quality of the work that we do. And yeah, let's dive, and I'll share a little bit more about our size and growth because I think it's important in understanding where this technology is going and how important it is to understand or to appreciate. Get all that stuff off my screen. All right, so first, why am I here? So I've got about 15 years of experience in simulation, modeling, and optimization, which is when we talk about digital twin, for us, we're talking about simulation-based digital twin. I'm going to explain a couple different types of digital twins, but that's what we'll focus on for most of this today. And so it's this. One of the neat things is people see digital twin as such a buzzword, but it's actually, at least how we approach it, the foundation of it is very proven. It's been around for 40 or 50 years in the form of simulation and modeling. And with the technology that we have today, we can just make it much more dynamic and in real time and drive different types of decisions than it had in the past. And that's how we approach digital twin. So we've got about 15 years of experience in this world across supply chain, logistics, and global operations. We've worked with industry leaders to move from concept to live digital twins in all over the globe and in all different types of industries. And my role is at SimWell as partner and chief revenue officer. We're a fast-growing global firm that is recognized for scaling digital twins across industries. All right. And so this is a map of SimWell's global footprint and growth chart. And my goal here isn't to pitch SimWell. It's really to show how this space has grown. So this is our global footprint. We started, my partner's from Montreal, I'm from Pittsburgh. And this is our growth chart over the last, since probably 2015, 2016, I think, starting. So you can see almost exponential growth. And this is from we have zero outside investment, but we have grown because the market for this is growing so much, and the need and the demand for this type of technology has grown so much, and that's driven by all of the uncertainty in the world, the pushes around sustainability and emissions, and a lot of other things that I'll try to weave into this as we go forward. And part of why I'm showing this too is that. With the economic, environmental, and political uncertainty that we're all facing, we're pretty optimistic that there will be continued adoption of this type of technology. All right, so let's talk about what we do with the digital twin and what we mean when we talk about digital twin. So organizations have a real world problem, right? Consider you're a vice president of a supply chain for something, or you're looking to cut cost, improve service level, reduce emissions. You've got a lot of competing goals, and along with those goals, you have a lot of outside variables that are impacting you too, like interest rates are going up, or high interest rates, inflation, volatility, and all the things that we're all dealing with today. But there's some real world problem, right? And because of our system is so complex of a supply chain or a distribution center or whatever it is, it's hard to go find a real world solution, right? It's hard to go from a problem to a solution without figuring out some things in between. So what we do with digital twin and with simulation is we build a model of the real world in a risk-free environment. And I'll share some examples of that today. And in that risk-free environment, we can test changes to the model or to the system. We can change what happens if demand increases. What's the impact to, like, what happens to capacity and utilization and throughput and all those sorts of things. We can also look at emissions. What is the impact to emissions, and what is the impact to cost? So with this tool, we can test different changes, compare scenarios, and understand what the impact of decisions that we make will be on the system. So we do that in a risk-free environment until we come up with a solution. So that solution might be a design for a network. It may be a schedule. It may be an inventory plan. It may be introducing electric fleets. There's a lot of different ways to apply this technology to what we're doing, but we find that solution in this risk-free environment where we can test anything. We can test over a shift, a day, a week, a month. We can test years ahead, and we can do that in a matter of a few seconds or a few minutes, typically in a model run. So we can really de-risk decisions, and we can understand impact before we go ahead and implement changes into the real world. So that's the idea of modeling. This is what we've been doing for 40 years and very proven. And when we talk about digital twin, we're taking this model and connecting it to real-time data, right? Maybe not real-time is the right word, but we're connecting it to live data that can help drive, that we can ask questions to, or that allow us to ask different types of questions to support an organization. So for example, maybe a hurricane comes through and shuts down a supplier. Well, now the system looks different, or the supply chain looks different than it did before. What was optimal whenever that node was up and running may not be optimal now. And with simulation, we can test how do we best operate to manage around that. It doesn't have to be disruptions, though. It could be we're introducing new products, we're expanding into a new geography, we're changing our suppliers, we're changing the modes of how we're moving products from here to there, whether it's around cost or emissions, but all those different things we can test. Then this is a graph that, or I guess a visual that people are probably pretty familiar with. It came from Gartner and about advanced analytics. And over the last couple decades or two, organizations have really focused around collecting data and what can we do with that data. And it's really there's been a big focus in the past around descriptive analytics, diagnostic analytics, but when we get into digital twin, we're looking more at predictive and prescriptive analytics. And what will happen if we do something? And then what should I do? And what are our alternatives? So I won't dive into this much more now. I just want to, because I think a lot of people are familiar with this visual. I want to align digital twin to that mandate, or not mandate, but that way to think about the world. So why does this matter now? Supply chains are under more pressure than ever. There's volatility, disruption, climate accountability, and it's all really hitting at the same time. And emissions reporting is moving from being optional to mandatory, and leaders need ways to test strategies before committing in the real world. And that's exactly where the digital twin comes in. This is one of my favorite quotes. For every complex problem, there's an answer that is clear, simple, and wrong. And that's something we share a lot, because there aren't other technologies that allow us to model a system the way simulation and digital twin does. AI is great for recognizing patterns and making predictions. Optimization is great for finding the best way to do something. But simulation and digital twin is the only way to capture a process or a complex system and test changes to it. It's different than a lot of other technologies or a lot of other things that we do, because we're not, of course, we use a lot of data, but we're not focused just on the data. We're focused on building a virtual representation of the process. So movement of goods, production, whatever it is, but we model the process, and then we feed data into the process. And that's how we start to see what is the impact of changes, or what will be the impact and outputs of the model once we make those changes. So this is why we can capture these very complex problems, very complex systems in a way that no other technology can. And what the real value comes when we do that, and then we integrate it with optimization in AI and other types of technologies. That's where we get into decision intelligence and decision support. So should we, and trying to understand balance and trade-offs between cost, service level, emissions, all the things that are priorities for an organization. So the layers of a digital twin. I mentioned earlier that digital twins are a bit of a buzzword, and I don't know if I'd even say they're a buzzword now, but they are used in a lot of different ways, and people use it for their marketing in different ways. And these are three that we see commonly, and we're going to focus on two of them today. But we start at the bottom. There's an asset level for digital twin, or IoT, vehicles, machines, a truck and a robot. We're trying to understand maybe when a piece of equipment's going to fail from vibrations, or there's lots of different use cases there. That's not what we're going to focus on today. It's a great use of digital twin. We're going to focus on the plant or process digital twins. And that could be a plant, it could be a warehouse, lots of different, it could be a mine. I'll give you an example of sustainability initiatives at a mine, and then at the value chain level or the supply chain level. So that broad network level that lets us test and optimize cross sourcing, transport, emissions. And that value chain lever or layer is where we can have an outsized impact on emissions. It's where you can run what if scenarios, weigh trade-offs, and make decisions that improve resilience, reduce cost, and cut emissions. So that hopefully that helps to put some structure to what we're talking about. All right, so let's talk about the anatomy of a digital twin. So this little graph here or chart shows three phases of this. So in the middle, we have our model of the operation. And that model can be a simulation model, it could be an optimization model, it could be AI, it could be lots of different things. We're going to show more examples of that in the next few slides. But we have a model, and then in order to have a digital twin, we need to feed that model with data from a system. So we're ingesting that data from whether it's a data warehouse, live data sources. We're building the pipelines to feed the model. When we're looking at supply chain, that's usually demand, supply, transportation information, emissions information, disruptions, risk analysis, things like that. Those are all getting fed into the model. And then when we have the model, that captures the variability, it captures the process, it captures all the variability that happens in a system. So in a supply chain, there's a ton of variability that can come in the form of how long it takes for a truck to get from point A to point B. It comes in how often a natural disaster happens. There's variability all across the supply chain, right? And that's a key part of what we capture in a simulation in digital twin. It helps us to identify those bottlenecks and understand the impact of disruptions. So we really see how the system behaves under stress. And by doing that, we're able to identify risks and opportunities before they happen. Typical outputs for digital twin are the KPIs of the system, whether those cost, service, emissions, utilization of resources. And then when we compare scenarios, we can look at trade-offs across different strategies or different policies. So over here, we're visualizing the outcomes of the model, comparing scenarios, dashboards, and hoping to support or automate decisions. And now I want to take a quick second to dive into modeling the operation and what we mean by this, or what's unique here. So modeling can mean a lot of things too, right? And people model in Excel and in spreadsheets. Maybe don't need to read all this text. This is just a video I've used before. But there's two models here, and they are exactly the same. Or not exactly the same. They are essentially the same. We have a person coming into a queue, a resource, which is a worker that's supporting them, and then they're leaving the system. Or they're leaving the line, a very simple system. So you can think about standing in line at a bank, or standing in line at a fast food restaurant, or whatever it is. You're standing in line, placing your order, and leaving. Now, in this model, these customers are arriving every 60 seconds, and the worker is processing their order every 50 seconds, at 57 seconds. And there's no and that's fixed every time. So customers come in every 60 seconds and it takes her 57 seconds to process. So that means that there is never a queue here. These people just flow through the system. Right? When we think about supply chains, that's how, when we use a spreadsheet, that's what we're modeling. Typically, we're modeling based on averages. And if on average, a customer arrives every 60 seconds and they're processed every 57 seconds, that's going to tell us there is no queue. Now, and go back to the beginning so we see this build up a little bit more. On this other side, it's the exact same process, but we have introduced variability into the system. So the average arrival time is still 60 seconds and the average processing time is 57 seconds, but the actual time is pulled from a distribution. So sometimes sometimes a customer arrives in 63 seconds, sometimes it's 70, sometimes it might be 40. And processing may take 57, 60, 70, 30 seconds. But again, it's pulling from a distribution. And we can see just by that, introducing a little bit of variability in that system, people start queuing up much faster, or they just start queuing up. You can see that in the chart down here, people in queue and time in queue. So if we're managing this operation and we do all our planning with not understanding variability and resource constraints and system interactions, we're going to assume this works perfectly as one agent, right? But if we introduce variability, we introduce resource constraints and system interactions and how those things change over time, then we get a more realistic picture of how the system is going to perform. And just this simple little process made a huge difference. Now imagine a supply chain where this isn't a simple process of people lining up, getting processed and leave. There's multiple warehouses, multiple manufacturing plants, multiple suppliers, multiple transportation options, right? It's a much more complex problem. And it becomes even more important to understand to capture those things that make the system unique. And that's what we do with simulation. Just going to take a second to bring up my questions in case you guys have any. Make sure I'm answering them. Actually, Jeff, I can't figure out how to do that. So if there are questions in the chat, please just interrupt me and we can answer them as we go along. All right.
I was talking and I was on mute, of course. Yeah, there are a few. I can give you one if I read this right. I'm not sure who this is from, but it's a question from YouTube. It says, in your experience, what are the levers needed to guarantee the quality of this mapping for system efficiency and optimization scenarios?
Yeah, great question. So when there's a lot to that question, but maybe I'll jump through to the end of how we do it. So once we build a model, it's important that the organization can trust the model and trust the outputs of it. If you can't, then it's not going to be used to make important decisions, especially supply chain decisions that cost millions or tens of millions or hundreds of millions of dollars, right? Or put that to risk. So we go through a process that we call verification and validation for every model. And that's where we're making sure it matches both the real world system as far as the process that we mapped or process that we modeled, and the outputs of it match the real world system. So typically when we build a model, we're comparing against the actual P&L, actual historical performance, and we're looking to get within sometimes 98, 99, 95, 90% accuracy in order to build confidence with the organization so that they can take decisions based off of what's coming out of that. So we can go a lot deeper. There's a lot of different ways that we do that, but that's how we're doing it. We're comparing it to the real world. And then once the outputs of the model match what's happening in the real world, we're able to trust that a change in inputs is going to show us what the output or show us what will actually happen in the real world with some range or some confidence interval.
Yeah, John, there's one just. There are other questions, but let me run because I think you answered this one. This is from Sent Hill. He says, will the simulator have a graphical representation of a digital twin, say the facilities? And I think you just showed that on the screen. That's why.
Yeah, and I'll show you some better examples of that
Okay.
too in a second.
Yep, that's it on the questions for now.
Okay, excellent. Let's keep rolling through here. And I think I figured out how to look at them, so be able to see them a little better here. All right, so we've seen this applied in a lot of ways. Network optimization, which is where to put facilities. We've done it in transportation and routing, so how to move goods. We looked at in distribution centers and warehousing, like order picking and conveyors. So we're looking at how to maximize throughput, reduce energy use, and then fleet electrification as well. How to reduce emissions while keeping operations reliable. So I'm going to share a few case studies or a few insights from some of these projects. So the first one is is network design or network optimization. So the challenge, let me jump over here. So in this case, frequent demand updates made it hard to keep production and shipping aligned. The company we're working with was constantly chasing changes and missing opportunities to optimize. So we built a supply chain digital twin to test network strategies and visualize the results, so they could see the impact of each option before acting. The outcome was clear. They identified 8 million in cost savings across production and transportation, and they built a repeatable process for continuous optimization as demand evolves. Of course, I can't show real world projects because they use confidential data. So I've pulled a couple screenshots here. So I'm going to start over here. So this is the comparison of a baseline supply chain and an optimized supply chain that's been optimized to support their growth over the next 5 years. And in this, it compares expected revenue, costs, service level, emissions, a lot of different data points, so that an organization can look and see, well, should we follow this process or this scenario or that scenario, and understand the trade-offs. Now, I think somewhat more importantly for this group is that within that, we can capture CO2 calculations for routes, for locations, for pretty much anything in the system. And then when we're running the model over, whether it's over a day or a week, or we're running to look at a few years, how the system's going to perform over a few years, we can calculate the emissions alongside of throughput and service level and cost and what have you. So that becomes a critical part of decision making. And we work with a lot of executive teams that are trying to figure out, how do they plan for the future? How do they build their network to service their customers that's cost efficient and meets their sustainability or net zero efforts? And this is probably going to be hard to see, but it's an output that is showing total CO2 emissions for a scenario and total profit for a scenario. Now, this is, when we do this once, we usually just call that a model. But when we plug this into their ERP systems or wherever their data is coming from, that's when we call it a digital twin. And then they can run this, whether it's once a year, once a quarter, once a month, once a week, once a shift, to help predict different changes, whether they're planning inventory or routing or what have you. Let's go to the next one here. This one's much different. In this case, we're going to talk about transportation and routing. So in this case, we had static routes, or our customer had static routes and unpredictable pickup volumes that were creating inefficiencies. Drivers were often underutilized or even running empty trips. This was for an organization that did recycling, and they were going point to point to pick up recycling from their customers. And so so we built a transportation digital twin that used dynamic routing, AI-powered pickup forecasts, and real-time driver integration through mobile apps and mapping tools. So the results for this were significant. The average pickup weight increased 52%, Empty pickups were reduced by 81%, and the overall efficiency, service levels, and driver satisfaction improved. So very different than that network supply chain level, but another example of digital twin, not just digital twin here, but we're integrating multiple technologies, simulation, optimization, AI, data science, data engineering to build a solution to support this sort of thing. I see a couple more questions. I'll lean in and answer. Will this simulator, oh, where did that? When will you choose simulation or an optimization model? Do you combine ML, OR, and simulation to do verification recommendations? The answer to that is yes, Stephen. Great question. So when do we choose simulation or optimization? It depends on the objective. Are we looking to find the best route for something? That's usually optimization. Simulation allows us to pressure test it. What happens if demand changes? What happens if we take trucks off the road for maintenance, or all those different sorts of things? So it really depends on the problem that we're trying to solve. And often we're integrating these to build decision intelligence tools or decision support tools that can help organizations and their people make optimal decisions at the point they need to make the decision, and they can do that faster. Do you see vibe coding being useful in these scenarios in terms of, say, creating dashboards? Good question, Sento. I think the answer might be yes, but the challenge is that these systems are so complex and the money that's invested into these are so complex. I think there is a inherent risk to vibe coding that the person that's doing the analysis and making the decisions here need to really understand the system. They need to understand how this is working, the data, so that they can so they don't make wrong interpretations of the system, or the AI doesn't make the wrong interpretation of the system. So I think that it can be used effectively in the right hands, and probably as that type of technology develops and people get stronger with it, or we get the right people, the experienced people that understand supply chain and understand modeling, doing that, they can iterate much faster. Did you use any specific modeling language to build the digital twin? We are software agnostic, so we use lots of different tools, including developing our own. A lot of the ones I'm showing today are AnyLogic, AnyLogistics, or custom coded. And the last one for right now, I have seen an article about agentic twin as an evolution of digital twin on the agentic AI era. What sort of change would you see on this era? I think that what we're seeing is more focus on decision support and decision automation. So the technology, of course, the technology will change, but when we talk about agentic AI, I believe it's around putting a point solution that's going to solve a problem or a set of problems. And so it is a next step for this type of thing, but it will leverage the processes that come from the simulation models. All right, so let's jump back into this project insight. I'll come back to questions. So this one is for a distribution center, the automated storage and retrieval system. Let me just hit play here. So the automated storage and retrieval system, along with the conveyors, were creating bottlenecks. That slowed down order picking and cut productivity at the workstations. So we built a model with an interactive dashboard so the team could test different scenarios, add picking stations, activating conveyor shortcuts, extending loops, and adjusting system parameters. And the outcome here was clear. Throughput and workstation productivity improved, and by eliminating wasted conveyor runtime and excess energy use, they not only boosted their operations and throughput, they also supported their sustainability goals and energy costs, reduced energy costs. This is somebody asked about visualization. This is a better example of the ones I was showing you. Supply chain ones are nice too, but they're just a map with nodes moving through. This little distribution center allows us to do a little bit more with the animation. Right. Yeah. All right, so let's hit play here. Get this going. So this is an example of a demo model. This is an interface to it. So You can make some basic changes to the inputs. Not the prettiest animation right now, but this was an older model that we did. But here, a mining operator wanted to reduce emissions by moving from diesel to electric trucks, but they faced a lot of uncertainty. What technology should they choose? How big should the trucks and the fleet be? How should the charging work? And when we're talking about charging, it's what type of chargers, what size, how many, and what schedule do the trucks need to charge on in order to maintain service? Because you can't have a big truck sitting dead in the middle of a mine. It's going to cause a backup. So we developed a simulation model of the mining operations to test all of those scenarios. It compared diesel against multiple electric options, explored fleet sizing, and evaluated charging strategies. And the outcome was a quantified picture of cost, performance, and risk, so they could see how electrification could cut emissions while still maintaining reliable operations. We've done this type of work in quite a few. So done this in mining, in different let's say corporate electrification initiatives. We've also done this for transportation centers. There's a lot, most large metro cities are adopting electric bus fleets. So we've been doing work in different areas to support those. Here you can see this is just a video, but they're picking between different elements of this, to understand whatever was important to this model. And this is not one that I was involved in. I'm not a mining person, so I can't intimately give you insights into what's happening here, but you can see kind of the depth and the level of how these things are being used to understand the system. I mean, if you look at this, if you look at this part of the network as these run through, you can imagine if you don't have the right if you switch to all electric and you don't have the right trucks, or you don't have them scheduled, or you don't have them charged at the right times and the right quantities, that you're going to have some significant bottlenecks and shutdowns that will impact the operation. So that's why this is so important. Same thing with a city center or a transportation center. If you don't have the right charging, you might have a bus that shuts down somewhere along a route, or that it doesn't shut down at the route, but you have to take it to the garage, and now you can't service that route and you're behind and your customers are upset. So lots of different scenarios there where this becomes critical. All right. So sustainability pressure points. So just listed a few things here that are driving a lot of pressure around sustainability and putting pressure on organizations, and how this technology is going to help them to adopt to it. So there's different rules, scope 3 emissions that people are putting more focus on, investor and customer pressure, all the climate rules. But these supply chains are under real pressure to decarbonize. But those are it's very complex to do it effectively, to do it efficiently, to maintain profitability, especially as all the other things that are happening in the world. So being able to model it in a risk-free environment, calculate emissions and throughput and all the key metrics for the system, and then compare those in scenarios is invaluable. So why now? The technology is ready, the regulatory urgency is here, and groups like the Linux Foundation are driving the open collaboration needed to make this real. So I believe the conditions are finally right to scale digital twins for this type of an impact. My key takeaways today: digital twins come in many forms, but supply chain twins are powerful because they model a whole system that a human cannot comprehend and predict without a tool like this. We've seen them deliver resilience, cost savings, and sustainability goals, and they align directly with the Linux Foundation's mission of open, transparent, net zero supply chains. All right. Thank you guys very much. Let's go back to the Q&A. If you have any more, if you want to, if audio's turned on to ask questions.
So John, this is Jeff. I did have one question around digital twins and AI. I know AI comes up in a lot of these conversations. Do you see, again, this is a projection, but understanding that AI models are out of date, and depending on what the AI engine you're using, LM, how far out of date is, they vary across chatbots. I mean, I think some of them are, in the pop ones, are still a year out of date. But if you're relying upon AI to do anything around optimization, has SimWell done any of that, or is it too dangerous? I guess maybe that's not the right word, dangerous, but is it not optimal to use AI because it could be out of date? And one of the things I was giving an example of is this was a scenario that we did way back a couple of years ago about it had something to do with supply chains in the supply chain group, but we simulated shipping coffee from Africa over to a grinding operation in New York City. But anyway, there was an accident. We simulated an accident on a bridge in which a truck was approaching. We asked AI take a different route, and so it came up with a different route. And again, the route was going to be a little bit longer and more emissions, but it wouldn't be sitting in traffic. And it sent that other around, and we found out from the IoT devices that it sent the truck through a bad area, not to pick on New York. And they broke into the truck thinking there may be watches or something inside there, and they broke it open and delayed the truck. And AI had no idea that over the past, since this road construction and road accidents in that area, it had no idea that that was an issue. It sent that truck into an area where it got delayed, it got broken into. Nobody wanted the coffee beans, but AI was not up to date. Do you see that as a problem still with AIs being out of date for some things you're trying to simulate in real time?
Yeah, for sure. And I think it depends on what problem we're trying to solve, what type of AI we're using, and how we're using it. So we're not in the use case, in the transportation optimization use case that I used with the recycling company. We didn't use AI for the routing. We used AI to predict when they needed to pick something up based on historical pickup data. So the AI was built specific to that problem, and it was part of the application that we delivered. So there's not a risk of it being out to date, assuming that we're getting, maintaining the input data or the information that we need to keep it running. If we were using an LLM like ChatGPT or something like that that's trained on past data, then that would be a bigger risk. But so I think knowing that this is if it would be put into an operational system, we need to be careful or just not use AI in that space. So I think for the most part, we're cautiously optimistic about where and just applying it in places that make sense or are safe or what have you. I don't know if that's a perfect answer to what you're asking, but hopefully it gives a little.
That's good. And there's another question that popped up.
Yep. Do you have any deep dive resources that you recommend? I've been especially curious since learning about Singapore's macro virtual digital twin model. Yes, there's people that I would recommend on LinkedIn to follow. I mean, one resource, if you go to SimWell, and then our resources page, we have a bunch of different case studies. We have like how-tos, we have different types of education. So that's just one that I know off the top of my head. If you wanted to, if I can think about it, or if you want to reach out, I'd be happy to share some other parts. There's so many, I guess part of the problem with my response, or part of why I'm hesitant there is there's so many parts to a digital twin. It's not just one thing, right? There's the data, there's the model, there's the scalability and flexibility of it. There's the outputs and how we analyze it, how we give those to the person that's making decisions so that it is actionable, and designing the system. There's so many, and there's its decision intelligence. How do decisions actually get made, and how does the model, how does the digital twin fit into the workflow to support that decision? So it's like there's a lot to think about when we talk about digital twin. Where can we see Gen AI to be used in digital twin? We're figuring that out. That's a great question, Stephen. We've done some we mostly just used experiments right now in terms of Gen AI examples where one interesting example is where we're feeding agents in the model with Gen AI to make decisions. So in an agent-based model, each agent in it can, rather than following a process flow, which is mostly what I talked about today, the agent can make its own decisions inside of the environment. And so we feed that through Gen AI. So that's a neat one. And then other things can be doing analysis with inputs or outputs, what have you. CloudStrife, that's funny. I'd love to, let me think about that a little bit more and give some good examples. Daniel, can you tell us more about how you create the initial models? For instance, can you integrate 3D object models that are refined in CAD programs? Yeah, great question, Daniel. So when we start a project or start building a model, we actually don't start with the technology. The first thing that we need is to define the system. So think about traditional industrial engineering, nothing too fancy. We need to know how the process works, because if somebody asked earlier about how do we trust this model, or how do we know we can use it, right? And we've got one of the steps of that is verification and validation of the model is making sure that it matches the real world. And so we start with having a process map of the real world. If it's a greenfield operation or supply chain facility, something being built, then we have some other, we still need to do something like that. We have some other processes to do it. But yeah, we start with that process map. And then there's a few key things we think about. What are the objectives of the model? We don't build a model just to build a model. That's a mistake that people often make, because we build a model to answer a specific question or a specific set of questions and to support a specific set of decisions. So then when we think about how we structure it, we talk about what are the objectives that we need to make, or what are the objectives of the project? What are the scenarios that we might want to test? Maybe they're different demands, different types of resources, amounts of resources, lanes, what have you. Then in the electrification example, it could be different charging stations, different size chargers, different amounts. But we can understand what the objectives are, what the scenarios we want to test, what are the key metrics we want to look at. Often when we're looking at supply chain, it's revenue, cost, service level, and emissions. And then we start looking at then once we have that defined and the process defined, we get into modeling, and we can integrate 3D object models. We usually pull in a CAD. At the very minimum, our animation's typically a CAD drawing with the animation flowing on top of it, whether it's a CAD or in supply chain, usually a map. But yeah, we could bring in those CADs, bring in 3D objects, and build based on that. Thank you, Daniel. Any other questions?
That was another question. Just saying thanks. Okay. Yeah, I don't see any other questions up there, John.
Damsey asked how many different use cases earlier. We built hundreds of models in our 15 years. And this has been around for a long time. So this has been used in many, many areas. Thanks, Paula.
I have another question, John, that kind of feeds into the work we're doing in the Linux Foundation around this. Have you done any installs where you're using blockchain technology to store key data, maybe asset data, and data that may be needed for auditability so that it's stored out on a blockchain, especially for carbon emissions? Have you seen that at all yet?
Good question. No, we have not done that, but where we typically start is the customer has the data, and now we're taking it and feeding it into the model. We're figuring that part out and then running the model. Okay. So I suppose there could be customers that have stored their data there, or organizations. That's a slide I took out because I wasn't confident in it, but I think that's the foundation, right? And then this is a layer, simulation or digital twin is a layer on top of that can be used to pull that data. And then similarly, decision intelligence is a layer on top of that that would be used to support different decisions around cutting emissions or meeting the goals and where we go.
So then in your use cases, then when you're building them out, you have a whole data architecture section or a session, I assume, that
Yes.
occurs. Okay.
Yeah.
Because we have
Especially
some
for
folks.
digital twin. What's
Okay.
that?
Oh, we have some folks on the call there from it's a standards working group that looks at data ontologies, and I was just highlighting that for them. I see them on they're part of one of our special interest groups.
Yeah, and that's a great question, and it's an important part, especially when we want to make a digital twin, right? If we're trying to solve a one-off project, like what should the supply chain network look like, then we may be able to just pull spreadsheets and build pipelines or whatever. But when we need a digital twin that can be used regularly to support decisions, then we need that standard data structure and format to feed into the models. Can you give us a high-level description of one interesting or unusual projects you worked on to do this kind of digital twin simulation modeling? We've done some really neat things. We've helped governments to prepare first responders for trying to think about how I can share this. Help first respond when there's a big event. Like I'm from the U.S. If you recall, there was a Boston Marathon bombing a few years ago that had impacted everybody around it. And and we built models to help understand when that happens, how do people respond to it, and then how do the first responders need to respond to it, and so that we can help train those first responders in what they do. So that was a really interesting project. We've done some really interesting, I've always liked the electrification projects of vehicles. We've worked in, and one of the best things about this world is that we work in just about every industry. So I recall one day we talked to somebody about how they wanted to mine things from the moon, and they were trying to figure out how they could best do that. And at the same time, we're talking to another organization about mining off the ocean floor, and totally different use cases. But how do we make those efficient and meet their goals? So lots of really cool use cases. Jim, I assume you now have a playbook you can leverage with any customer to help guide data science and governance to be successful. Yes, I wouldn't say that we're a governance. We don't give a governance framework, but we guide them on what we need to be for the project. So we don't consult on organizational data governance, but we do that for the project or the model that we're building.
Yeah, John, thanks very much. Yeah, what I was thinking was, and you've described this pretty well, I think. I come up to you and say, hey, I think I want to make a digital twin out of X, whatever I'm interested in. Cell phone population within a zip code, and you have enough to say, okay, well, here's key data elements we're looking for. This is the data quality we're going to need to look for. You may need to go back and scrub your data and clean these various things up if you want to be able to get to a level of confidence around the model we're going to build.
Yep. Yeah. Then some of the data needs to be more accurate than others. Sometimes we can, so we'll do sensitivity analysis. We'll do, and we're typically trying to use distribution. So whether we can have historical data to fit to distributions that the model then uses to figure out how long it takes for one thing or the other, whatever that data needs to represent. So there's different ways that we attack that, whether the data is good or not, or if it's there or not. We've rarely run into systems where we can't build a model that is meaningful. But of course, if there's no data or it's absolutely terrible, then that can be a challenge.
Yeah, that's great. Yeah, this is Jeff again. So I know our hour's up. I see, I think we're done with all the questions. I see David Boswell's back on there. David, is there a mechanism where if people have additional questions, they can submit them? Or maybe, I don't know, if John, is there something you have where people want to reach out to you?
Yeah, I should have put that in there. If you go to SimWell.io and submit the form, if you're interested in anything, you can also connect with me on LinkedIn, John Santavy, JONOH. My email is jsantavy@simwell.io.
And Jeff, that's a good question about where people can go after this event to ask questions. I would, if you want to share the link to the climate special interest group mailing list, that's probably a good place for people to go. So maybe you can share, just say a minute about what the mailing list is and how it's a forum for people who are interested in this topic. And if they want to sign up, they can go and ask questions there.
Yeah, let me go ahead and post that real quick. I think you'll get it first. Take a second.
Yeah, I can get the link if you need it.
Yeah, if you've got it in front of you. Well, I've got it. I got so many things sorry open on my screen.
Yeah, I just put that in the Zoom chat. So the Linux Foundation Decentralized Trust hosts a number of different open source, projects, and we have all our infrastructure is open. So one of the things you could use is the Climate Special Interest Group has a mailing list that you can subscribe to, and you can introduce yourself once you join and post questions. So that's probably a great place to go. If you have additional thoughts, comments, suggestions on the topic, please feel free to go there. The community also uses Discord. You could also join us there. I think the Climate SIG group specifically, though, uses the mailing list more than Discord. So,
So we do, yeah. You're right. No, you're right, David. Yeah. Did I lose you? Oh, Dave's on.
You got a little
No.
quiet there, Jeff.
No, I was flipping around on my screens, but for any people that are still on, we will. This is an exercise out of the Linux Foundation, and we're just doing architecture work. This isn't SimWell's got their own architecture, so but this is for open source, and so we're going to actually do a presentation probably with our graduate student in about 6 weeks, maybe 2 months, around Halloween, a good time to show our ideas around. Again, it's related to open source software, and so things that I'm showing on the screen, I think you can see, are actually stuff that we're saying. How to do architecture. We're picking on digital twins and how to do enterprise architecture, not a solution architecture. And so you can see like the slide I have right now, this is security architecture on IoT devices. This is a much deeper dive than what John's talking about, but this is where we highlight open source software, in this case for IoT devices. And so I know I'm not doing a good description of what we're doing right now. It's somewhat related. It is related to digital twins. Why are we doing it? Why we're picking on digital twins? But there's a lot of stuff around data architecture, exercises, and it's good learning space for people that are interested in using open source software and doing architecture work. Again, this is not a blueprint on how to build necessarily a system because people have their own languages, but it's ideas at a high level architecture level to say, if you want to think like an architect, you have to look at lower usage parts of the system you're eventually going to build, and then think at a higher level how you're going to do things. And so it's quite complex. But and the other thing I want to just make sure highlight is that this is all geared toward using blockchain technology and cryptography. So that's one of the questions I asked John earlier about blockchain, but this is making assumptions about a use case where people have to really track on our supply chain their carbon emissions and be able to have a immutable source for auditing and a data ontology. And so that's what this was driving all this right here. We're going to do this demo probably in 2 months. But it's a different flavor of what we're talking about here today. John's got more specifics that people are very interested in about how you experience and how to build out digital twins and where they're being used today.
Great. And I think there's a
It-
question in Zoom chat if that's something that's coming up. So you're gonna host that. We'll host that as another meetup so people can just keep an eye out. We'll post that. Are you planning to do that as another meetup, Jeff?
That would be another meetup. So, I don't have a firm date on it because we have to organize things quite a bit. Some stuff, unfortunately, is probably my fault. Is scrambled a little bit.
No worries. What I can do,
John,
what I can
when I'm
do-
using John was very organized, and so I'm doing notes down. But we gotta like with Edward, you can see him on here. We're gonna move the stuff around so it's somewhat presentable. Again, the focus is going to be around using blockchain technology for things like IoT devices, manual entry, screens that do updates, things like that. And so again, that's going to be in about should be about 2 months,
Okay.
but
Well, what I can
maybe
do, Jeff,
6
is
weeks. It'll be a technical meeting.
I can email everybody who signed up for this meetup and send them the details of that when you post it. So if people are wondering how to find out more about that, I'll send an email.
Yeah, I think we can post that pretty soon. Maybe that's a good idea to give us a target to make sure that we move faster on our work. But again, it's a different it merges well with what John's talking about. We have the very technical piece underneath that people involved in technology and architecture are interested in pursuing and looking at, but John's got more of those things that they've already done that, and those are key to business leaders. And so it's very fortunate that we got John to give us a presentation today. But yeah, we do have that. I think you can see some screens that I have up, but it gives an example of these aren't real screens, but these are screens architects have to put together to see how data architecture works underneath. So I'm just trying to give a flavor of what we're going to be doing in 6 weeks, presenting very detailed about architecture around things like this, real-time screens. And again, please don't expect the intricacy that SimWell has around this. This is more of an architecture drive to show how to do things from an architecture standpoint. So people that like that will get a big kick out of this, I think. We are, but we're also trying to get this thing done so that we can present it and get a lot of feedback from other architects, technical folks to say about architecture. That's going to be the driving folks, or driving purpose around our next meeting is to get people more interested in that slide pack that I'm showing. And I'm an architect from decades, and one way to get architects to comment about architecture work is to present something to them so they can grab it and just shred it around in pieces. It's hard to ask architects questions, and they want to see things and then be able to give suggestions. So again, this is a take on blockchain technology cryptography with a use case around a digital twin. But again, I emphasize the digital twin is not sophisticated like we're talking about. We had John give out today. But yeah, maybe David, we can talk about putting a target out there, and it'll be a meetup again. John, you're welcome to send an invite to John. And John will take a look at it and go, what on earth are these people doing?
Sure, John. Great to have you back.
Looks interesting.
So I think, yeah, I thank everybody for, especially John, for the presentation. We really appreciate it. We got a lot of people that this is a very well attended meeting, and on a global basis. And there'll be a lot of people that sent me emails around the YouTube because they're in different time zones. There's impractical for them to attend. So there are a lot of folks that will be looking at the YouTube video. And again, we really appreciate the talk, and also appreciate everybody being on the call and the questions. The questions were good.
Great. Well, thank you, everyone. Thanks, Jeff. Thanks, John.
Yep.
Yeah.
Thanks, everyone.
Thanks, Jeff.
Bye.
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 Thanks again, John.